So today we are going to see today question of Leetcode. So today we have given this question, that is 2359. Find closest node to given two nodes. Okay, so we have given two nodes and we have to find the closest node, right? So let's see and read the question. You are given a directory graph of n nodes, right? We have given a direction for each node, and it is going to where? Okay, from 0 to n minus 1 we have given. Each node has at least one most outgoing edge, right? And the graph is represented with a zero index array of size n. Next, indicating that there is a directed edge from node I to edges, right? If there is no outgoing edge from I to edge, then we will have what? Edge of I equal to minus 1. You are given also two integers, node 1 and node 2. Return the index of the node that can be reached from node 1 and node 2 both, such that the maximum number between the distance from node 1 that and from node 2, maximum distance between, that is node 1 is minimized. If there is multiple answers, return the node with the smallest index, and no possible answer exists, return minus 1. Let's see, the problem represents a directed unweighted graph. Okay, and we have given what? N nodes we have given. So for each node, what we have to do, each node can have at most one outgoing edge, right? And for each task, right, and our task is to find what? We have to find the closest node, okay, from the two given nodes. We have given node 1 and node 2, right? We have given, and then what we have to do, we have to do find the maximum between the distances from node 1 and node 2, so that node is minimized over all the nodes. If there are multiple answers, we need to return the a node with the smallest index, and if not possible answers then exist, then we have to return what? Minus 1, right? Understood? It means, let's see the example one here. Okay, so we have given what? These nodes we have given, right? Each node has a direction and it represents where it connects, right? And then these are the edges given: 2 2 3 3 minus 1. We have given 2 2 3 and minus 1. This is the array we have given, correct? Now what is saying, we have given node 0 and node 1, so we have given node 0 and node 1, correct? So we have to find what? The we can say maximum distance between maximum distances from the node 1 to node 2, right? So if let's suppose if this is node, we have given node 1, right, and this is node 2, correct? So we have to find the maximum distance, right? So how we will go, right? So we have to see, we will go like this, right, here to here, right? So see the explanation. The distance from node 0 to node 0 to node 2 is 1. Node 0, this one, right, this is 1, this is the distance is 1, correct? Now, and the distance from node 1 to node 2, correct, is 1. This one, node 1 to node 2 is 1, right? The distance from the node 1 to node 2 is 1, correct? Now what is saying, the maximum distance, those two distances is what? 1. If we'll do find max, right, then what we will do, we have to find 1 and 1, the math dot max, right? Remember, so we will, if we calculate, we will get what? 1, correct? So it can be proven that we cannot get a node with a smallest maximum distance than 1, right? We cannot get we cannot get a node, right, with a smallest maximum distance than 1. There is no like that. So what we have to do, so we have to return 2, right? This is the node we have to return, right? So we'll get we will return the smallest index, right? We have to return, and that's all. So let's go and see. Okay, this was the index, and that's why we are returning this one. Okay, let's see to the depth of first approach, and we'll see this one. Okay, so see, we have created one this is the functionality that we have given, right? The edge we have given, and nodes 1 given and node 2 we have given, right? Two things we have given, node 1 and node 2, and all the list edges of array we have given into the array form, right? So what we will do first of all, we should calculate two things, distance 1 and distance 2 we will calculate, and we will fill the default value with the maximum value, right? Like if we'll say I'll take this array, right, and I'll put the maximum value of the array here, all this one. Okay, now what we will do here, distance at node 1, right? Let's see, this is the distance at node 1. Okay, so we are putting the default value 0. Similarly, distance another array we have same like this. What we will do here, we will put the default value 0. This is distance 1 and this is distance 2. Okay, now we have visited node info, in which we will pass the default value false here, right, and we'll take the default value there, right. Then we'll take visited to, and we'll store another information of the visited info, right, we'll put there. Then what we should do, we have taken visited node info, right, and visited to, visit to will take, we have taken. So what we will do here, we will add the information there, right, uh, default value, both place we will add the default value. So this will look like this one. This is a v1 and there is a v2. Okay, so at all the places, like if someone will pass what visited at node what 0 here, right, so it will come false, right. Similarly, it will come by default value is false 0, but once this is visited, we have to make it false to true, false to true, like this. Okay, so how we'll do that, we will update through what this DFS utility method. So we have created one DFS utility method here, and what we are taking, we are passing the node, right, the node we will pass, and the edges we will pass, distance we will pass, and the visit we will pass, right. So we visit at that node, we will make true, that I was saying this one, right. So we will do true. Then what we will do here, for all the, we will get the neighbors from the after passing this edge, right. So we will pass the edge at node. So if you pass the node of what, let's suppose we have we were given 0, we have given 1, we have given 2, we have given, and 3 given, right, like this we were giving, right. So if I pass this node information, so I will get the information neighbor is this, right. So we will update the neighbor, we will have our neighbor now here, and then what we will do, we'll check if neighbor is not equal to -1 and it's not visited, means we have neighbor doesn't have -1, means it has some value, right. And then what we will say, if visited not equal to false, right, means by default we have true value. So it should not be true, it should be false. If it's not false, means that we have to visit it, right. So what we will do, we will update that neighbor distance, we will update 1 plus this. So if I'll get this information, this is the neighbor of this one, right. So what we will do, this distance we will update, and plus this we have this one, right, distance of this node we will pass. So we'll add 1 plus distance of this, right. So this is done. After that, we will call this DFS lottery internally again for this one, right. We have to go to DFS, right. So we'll pass neighbor, age, distance, visit. So it will make the loop again, and it will update this distance, then this distance it will update, right. So we will get this. Finally, we will have all the distances information. We have 0, let's say 0, we have 1, 2, 3 we have, right. So all the information we will get here, right, all the information we will get there. Okay, now this part is done. Now what we will do, we'll take two variables, that one variable will take -1 and one variable will take max value. Okay, so this is minimum and that is maximum. So from the node, the given node. Okay, then we will make the loop current node to the last length. We will start from this node and we'll go to like this, we'll go all the nodes, right. So we'll check, and we'll check which, if node at distance and from the distance to at that node, distance from this node and from this node will pass, and we'll check the distance, which one is minimum, we will update current is minimum, and if not, then whatever is the maximum we have, that will update our maximum right here. So this maximum will come here and minimum will come here, right. Finally, the minimum will get updated, right, from -1 to we will get some value, right. So that will get updated and that we will return there. Okay, so I think that's all we have. So thank you guys, thank you so much. And if I'll talk about the time complexity, right, we have made the for loop here, right, and we are moving to all the nodes, right. So we will say O of n is the time complexity. We are not taking extra spaces, but we are taking for visited and the distance that have the same length, right. So we'll say O of n, right. O of n plus O of n is come O of n. Okay, you can say. So space and time complexity remains same. Thank you guys. If you like this video, please hit subscribe, and if you have any doubt, please ping me in the comment box.